we continue on here, we're going to start talking about three-dimensional figures, and a lot of vocabulary. We'll talk through the general shapes, some of their characteristics, and then we'll start talking into how to determine or how to calculate possibly the surface area, the volume of our different three-dimensional figures. So here as we look at them, a lot of vocabulary, overlapping. Hopefully some of it is familiar to you. But let's see here, identifying three-dimensional figures. A polyhedron, just in general, is a closed three-dimensional figure made up of flat polygonal regions, flat surfaces. These would not be considered polyhedrons because they have something rounded on them. So the flat surfaces. Now the different types of flat polyhedrons, you want flat surfaces. Sorry. So you might see that a side would be a face. Okay. So when we look at this image, we could say that this prism here is the top is a pentagon, the bottom is a pentagon, so those are my bases. Usually when you have something like this, would be called a right prism. It's called a right prism because it has 90 degrees straight up sides from its base to its top. So in this case, this right prism has 5, 6, 7 sides, or 7 faces. And again, there was one here. You can see the top is a face, the bottom would be a face, and then of course you have all these sides that would be faces. Then looking over here at this pyramid, it has 5 faces. You have the 5 sides and then the base below. Understanding that the edges of a polyhedron would be where my faces intersect, sort of a line segment. So that would be an edge, an edge. Here we have the edges where the sides of my pyramid intersect. And then a vertex. A vertex is an intersection of 3 edges of a polyhedron. So a vertex is the intersection of 3 edges of a polyhedron, forming a point, basically. We see these little points. If you were to hold that in your hand, it would be sharp at those locations, and that would be an vertex. Okay, and then of course the bases we talked about. That is a prism, and this is a pyramid. Now when it comes to your cylinder is not a polyhedron, but it does have 2 bases. The cylinder, its bases will always be circles. So a cylinder is a solid figure that has 2 congruent and parallel circular bases connected by a curved surface. So parallel basically just means, it's like a can. The top and the bottom are parallel to one another, and then you have the round sides. The cone, similar to a cylinder, you have a circular base, but only one circular base. Your rounded sides come up to a point called the vertex. Okay, and then a sphere is a set of all points in a space equidistant from a given point called the center of the sphere. The sphere has no edges, no faces, no vertices. Okay, so just understanding some of the terminology there. Polyhedrons, they do have names. When you think about looking, each one of them has a specific name, and if we don't have those exactly, but some of the things will sort of stand out. When I talk about a triangular prism, my bases are a triangle. A rectangle, my base is a rectangle. A pentagonal prism means my bases are a pentagon, and that would be something with 5 sides, pent. And then of course we start repeating it. My base is a triangle, my base is a rectangle, my base is a pentagon. So thinking of those kind of things. Right and oblique. So here, looking at this study tip, it says, in right prisms, the bases are connected to each other by rectangular faces. Right angle, rectangular faces. However, in oblique pyramids, at least one face is not a rectangle, because it's going to be a parallelogram, because it's going to be sort of a pushed over rectangle. But I will tell you, the height is still the same though. You still calculate the height, coming up with a 90-degree from one base to the other. Okay, and then here's just a quick snapshot of the formulas, and we'll talk about more of these later on, but we did just talk about this one. These are the formulas provided by the state for our tests. Let's go back and look. A triangular prism, okay, that's what we call it. Okay, so Plato came up with some solids that he felt comprised the entire classical elements. We're not going to differentiate too much there of having to identify what they are, but some of the things continue. An octagon is 8, hexagon is 6. So these things are just, we'll work more with these. Identifying properties of three-dimensional figures. Again, we talked about the names, but we'll practice with those, understanding the faces, the sides, the vertices, the edges, so being able to calculate those. So determine whether each solid is a polyhedron, then identify the solid. Okay, this is an 8-sided. It's hard sometimes to see a three-dimensional figure on a two-dimensional piece of paper or screen, but this is intended to be an 8-sided image, right? That's like one side is a triangle, sort of, and then we can see that. So your lines make up your edges. Of course, where the points come together, you have vertices. So this solid is formed by flat surfaces, so it is a polyhedron. There's no base, no distinguishable base, but it does have what looks to be 8 equilateral triangle faces. 8-sided, we're looking for a 8-sided octahedron. And I would just say here, they have come up with a series of all the faces, because all the faces are the shape of a triangle. That's why we have triangle QRU, triangle QRS, and here is QRS, is that back piece over there. So we've added those up. All of our line segments, all of our edges are our line segments. So we have those, and then my vertices, we should have what would be 6 vertices. I got V, S, Q, R is back there, T, and then U. So just keeping those things in mind. The cylinder is not a polyhedron, because it has a rounded side. Polyhedrons are all flat surfaces, and it has 2 congruent and parallel circular bases, so it is a cylinder. And this is the kind of thing that you should be able to identify these characteristics and identify what a shape is based on those. So again, cylinder, we have a radius included in the cylinder, so those would be congruent top and bottom. We know that it's a 90-degree going up, so different things like that. Sorry. All right, so being able to model things, I would just say, identify the three-dimensional figure that can model the beverage container here. Looking at this, I would say that could be a cylinder, and if it's a cylinder, then it's not technically a polyhedron, because it has rounded sides. Okay, just looking at the basic shape of a cylinder. Okay, not perfect, but reasonable. And then it says, identify the three-dimensional figure that can model the top of the camping lodge. Okay, obviously, looking at this camping lodge, I hope you can, let's see, it could be, I have this triangle right here, and I could almost look at it and say that could be a triangular prism. And then it says the top of the camping lodge can be modeled by I'm going to go with a gosh, what was that? That's what I said. Interesting. A triangular prism. And the model is a polyhedron, because we don't have any rounded sides that we can necessarily tell. So using those characteristics. Now, Here's where we start to actually do the math. These are understanding our definitions. Now let's look at the math. Measuring three-dimensional figures, understanding surface area, understanding volume. That ties into us learning perimeter, learning area, and learning circumference. So keep those things in mind that we're now just using that information. Surface area. Surface area is the sum of the areas of all the faces and side surfaces of a three-dimensional figure, okay? If I were to have a cardboard box, the cardboard box is the surface area, and then what I put in the cardboard box, if I filled it with sand, that would be my volume, what goes inside. So the difference there, if you were to paint something, that is painting the surface area. If you were to fill something up with water, that is filling it up with volume. So just being able to distinguish between what is surface area and what is volume. If you can paint it, it's your surface area. Now, here's some formulas that our text will use. It's available to you. But what I will point out is this. This is what the state of Tennessee provides us for formulas as we are working on our end of course test. So if you don't memorize them, they are available to you. You just need to be able to recognize and utilize the characteristics in the formula. So, for a cone, the volume is 1/3 pi times the radius squared times height. They've defined them all. What may throw you for a loop is you need to make sure that you can distinguish between slant height and regular height. There's my cone surface area. So surface area, pi times r squared plus pi rl. Okay, so cylinder, 2 times pi r squared. Well, a cone only has one base. This is a circle. That's the area of a circle. This is the area of a circle, but since a cylinder has 2 bases, we have, when we're doing our surface area, we have to do it twice. That's why we multiply it by 2. So just being able to work through these. And you have a rectangular prism where it gives you your surface area, but you have to calculate surface area on all your prisms. They're just going to refer to it as a right prism. So when we have a prism, thinking about a right prism and looking at it, the volume is going to be big B, which is the area of the base, times your height. And all of our right prisms, that's what we do. Before, a few pages ago, when we looked at that pentagonal, whatever, hedron, that's not a very good one at all. But we would calculate the area of the surface area of the base, and then we would just multiply it times the height to get the volume. So one of those things that you have to understand, and we'll practice with those. But they're defined, but if you don't know the definitions, then it makes it very difficult. Okay, so again, there you go. I did cross this one off just because it is not the same as what our Tennessee reference sheet provides us, but working with it, you'll get a lot of practice here. Let's see. I'm going to come back here real quick and just talk about these and making sure that we are clear. Again, it saws the perimeter of the base. Here we are talking about the surface area. Not going to worry about that. The volume. The area of the base times your height. Okay, the volume of a pyramid or is 1/3 the area of the base times height. Coincidentally, the cone is 1/3 the area of the base times height. So when you have these cone shaped or the pyramid shaped, you have to multiply your answer by 1/3. And then for surface area, there are formulas for surface area, but you do need to understand that L is your slant height. That's the outside versus the height, which is at a 90 degree. Your slant height is the diagonal versus your height is a 90 degree or perpendicular line going from the top to the bottom. So being able to distinguish that. And then again, for your sphere, we have the radius. That's what you need to know for a sphere. Everything else is in the formula. R is the only thing that you have to find or replace, which is your radius. So just looking at those and being able to determine what each one of those definitions are, and we will work with them. Surface area for a rectangular prism is right here. So we can use that. And then see here, finding the measures of the 3 dimensions. Okay, so here in this example, here's a good example too, where they discuss the difference between height and slant height, in case you're in question. Find the measurements of the 3-dimensional figure. So it says find the surface area and the volume. Let me see here. The surface area, give me the formula here. The surface area, right, is pi times the radius times the slant height plus pi times radius squared. Okay, so when I look at my image, I need pi, and I know that. I need my radius, I need my slant height, and I need my regular height. Nope, just my slant height, sorry. So here, radius, this is my radius is 15. Need to be able to look at that. So my radius is 15. My slant height, I don't have that, but what I can do is if I have a right triangle and I have the 2 lengths, this would be like my A, my B, and my C, and I can use Pythagorean theorem to find out what the slant height would be. And that's what they've done here in this example. They've turned around and said, C is my slant height, so let me solve for my slant height because I need that in my formula right here. So when they did that, they determined a squared plus b squared. They did the math. This would be, 64 plus 225, which is 289. Then they found the square root of both sides. So C is going to be the square root of 278 or 17 right there. So that's my slant height. They plugged that into the formula and then came up with the answer, right? Pi times my radius times my slant height plus pi times my radius squared, and they came up with 1508.0. Thank you, calculator. Okay, so the surface area, they were able to calculate that by plugging the numbers into the formula. And then for the volume is 1/3 times pi times r squared times h. We have r, my radius we said was 15, and my radius, or my height, was 8. They plugged those into the formula and came up with a value for volume, which is 1,885. And I will just say that it is cubic inches, which is written as inches cubed, because you have a 3rd dimension, 3D 3rd dimension, so that's why it is to the cubed power, because we are multiplying those times themselves 3 times. And then for units squared, inches squared, that would be inches squared for area, because that is going to be length times width, which is 2 dimensions. And then it also talks about it right there. Looking at the check, trying to find the surface area and volume of a rectangular prism, round each measure to the nearest tenth. Okay, volume's pretty easy. Volume is simply the area of the base times your height, and the area of the base is going to be length times width, and then we're going to multiply that times height. So that is going to equal 5.2. Call that my length, call this my width, call this my height. Length times 10 times 6 is going to equal, let's see here, if I do this, this is going to be 52 times 6, which is going to be equal to 312. So 312 centimeters cubed, cubic centimeters, is my volume. Surface area is going to be a little bit different. If I go back and I look at the formula, take it over here so we can look at it. So surface area is 2. 5.2 times, see, this gets a little bit cumbersome here. 5.2 times 10 plus 6 times 5.2 plus 6 times 10. And then you just work this out. You know, you got 2 times 52 plus 31.8 plus 60, 2 times, 100 and 100 and I'm having trouble here. 8.3, 143.8. So multiplying that together, you get 6. Let's see here. 782, I believe, is going to be the answer. Centimeters squared. Hope I'm right. Doing math in public sometimes gets me in trouble with no calculator. Okay, so just being able to calculate that information using our formulas. Really, once we get to a formula, what I'm going to ask you to do at the very least, a lot of students will tell me, I just put it in the calculator. That's fine. I want you to show me what you put in the calculator. So I would expect you, at the very least, to have written that down. At the very least, to have written this down. Because that tells me what you put into the calculator. So, and then let's see here. Moving on. Now they're talking about calculating measurements using three-dimensional models. Goodness, this one is long and drawn out. But hey, underwhelming, the size of the New Year's Eve ball. It's a geodesic sphere that is 12 feet in diameter. It weighs this many pounds. It is lit by this many lights and is covered with this many crystal triangles. Okay, how many lights are contained in the ball surface within an area of 4 square feet? Well, we don't. It's bigger than 4 square feet, but we only want to utilize 4 square feet. So finding the surface area of the ball. Because the diameter is 12 feet, the radius is going to be 6, right? Because your radius is 1/2 of your diameter. So the surface area is, excuse me. The surface area should be what? 4 times pi times r squared, which comes to 6, right? R, which is 6, which came to about 144 pi, because you got to remember this would be 4 times pi times 36, which 36 times 4 is going to be 144 pi. Or if you worked it out as a decimal, we would have 452.4. So the surface area is going to be approximately 452.4 square feet, or square feet. Determine the number of lights within the area of 4 feet. So all we're doing now is we're going to convert. We want to not do all of it, but just 4 feet. So if we have 4 feet, and then I'm going to cross multiply, right? Because I know there's this many lights out of this many feet. So I'm just multiplying 4 across divided by this, and it comes out that there are approximately 2,086 lights. And there are 286 lights within the area of 4 square feet. Okay, so that's just being able to convert, going from the entire object to just a portion of it. And this is a good example right here to cross multiply. If I know that all of the lights 32256 out of all of the area, then I want them to equal, my area is only 4, and then X, because I'm trying to figure out how many lights are only in 4 square feet. And then there you go. That's a lot of people will be very comfortable with that kind of combination, because I simply do the cross product property and I'm able to calculate the same answer. So just keeping that in mind, there's different ways to look at a problem and work it out that seems a little bit easier to us. And then if Tony is repairing a section of the ball that has the volume of 8 cubic feet, how much does the section weigh? Well, calculating the whole volume again, the radius we said was 6, and then this would be radius, and then radius is 6. 6 times 3 is, gosh, I'm having a trouble coming up with that number. But when we multiply this all out, let me do it real quick. Okay, so we have 216 times 4/3 pi, and then we can simplify that. And there you go, 288 pi, or about 904.8 is the volume. So find the volume, 904.8. Now, pounds. Oh gosh, weight. Calculating the weight, sorry. Determine the weight of the section. Okay, so we have the entire ball, right, which is 11,875. The entire ball and its volume is equal to some weight over the 8 cubic feet of volume. So this is where we can just simply cross multiply. I know they got a lot going on over here, but if we look at it, cross multiply, and you end up with 904.8x is equal to 8 times 11875. And then, let's see here, 904.8x is equal to, let's see here, 0, 4, 56, which is 60, put a 6, 64, that's 70, put a 7, 8, 15, put a 1, 9, I believe that is it, divided by 904.8, divided by 904.8, and then x is going to equal approximately, one moment, approximately 105 pounds. So just working through that to determine what the weight is they have going on there. Not going to do this complete problem, but we do have the pool here in this check. Mateo is building a new pool. A cross section of the pool is shown, okay? And then the volume of the pool to the nearest tenth, what is that? Remember, to calculate the volume, this is an irregular shaped item, so there's no definite formula, but to calculate the volume of a right prism is equal to the area of the base times the height. So you just sort of have to stand this thing up on its side and pretend that, you know, this is the base. This is actually the base that you see right here. Okay, that would be the bottom and the top. And then when we look at that, we would have to probably break it apart and come up to calculate the area, because it's not a perfect shape, but I can break it apart into usable pieces. I know that this little square is 30. I know that if I look here, I have, this is 12 times 10, which is, because it's a rectangle, right? That is going to be 120. I could look at this and say that this distance, if this is 6, this is 10, that makes this distance right here 7. So I know then that the area here is 7 times 5, which is 35. And then I can also calculate the area of this triangle, because I can calculate my height and my, for example, this is 7 and this is 7. So I know 1/2 the base times height. So I can calculate the area of this base, and then whatever that is, I'm going to multiply it times the height. And in this case, since I took this prism, right, I took this prism and I stood it up on its side, because this is now the bottom, the height of this would actually be the 15. So able to come up with the height being 15, and that would give me my dimensions. So, and then there you go. That is sort of talking through what I could do with that problem. We're going to do a lot easier examples in class, or our classwork's going to be a lot easier than that, but just being able to look at it and sort of analyze what we're doing.